today's problem is comparable to a Singapore secondary school math Olympiad problem, folks. Singapore is all I'll say. Okay, so again, it's all right. This is Singapore secondary school math Olympiad back in 2000. It's similar. It's comparable. Okay, we have A, B, and C real numbers, and we're trying to find the maximum value of this expression right here. Now, there's the natural regrouping, and I wrote most of it out just to save a little bit of time, but if you regroup in this fashion, you get the A and B terms together, and then the C terms together. There's some nice things that happen. For example, these three terms have a common factor of 5. If you take that out, this would become 5 times A minus 4B quantity squared, right? So that's easy enough after you factor the 5 out. Okay, now over here, this is a little bit different here. We need to insert a constant term that will allow us to write it in something similar to this form. And so you guys, this is a very, very popular result called completing the square. What you do here is you take, owing to an algebraic identity, you take half of the coefficient of C, which is a -6. So you get 7 times C minus 6 quantity squared, right? Now notice that this expansion would give you C squared and minus 12C for free, right? But it also kicks off another constant term, namely 6 squared, so you would have 36 here. Okay. And then plus 271, which is still the constant that's lingering. Okay. Now let's carry on. So the very same thing right here. I'll just do this piece. Well, it's all right. We'll just write it. Okay. So 5 times A minus 4B quantity squared. And y'all, if you'll notice what happens right here, 7 times 36 is 252, right? So what we can do right here, we can balance it out by just stating this. We can write 7 times C minus 6 quantity squared. Now, again, 7 times 36 is 252. So if we subtract that away, see, we have this statement. And y'all, if you don't trust this, for those of you familiar with completing the square, this is a piece of cake. But if you haven't seen it before, this looks like what happened. Where did the 252 go? Well, we had to subtract it off so it would still equal the original expression up here. See, really, we just had C squared minus 12C, right? That was it. But we chunked the 36 in here to accommodate the creation of these two terms by this binomial factor, okay? So notice that what happens right here, and I'll circle this constant part to avoid having to write it down again. Okay, so this is 19 right here, right? So notice that's all that's left from the constant's point of view. So we see that if A is equal to 4B, and you can verify all this stuff. It's pretty easy to check these for integer values if you want to. But that would imply this whole piece was 0, right? If you just put 4B right there, this whole piece is equal to 0. And if C is equal to 6, this entire piece up here would become 0, right? So that means 19 would be your minimum value. What did I ask for? Oh, yeah, we're looking for the minimum, folks. Sorry. This should be minimum. I don't think there is a maximum, so let me replace that. Minimum. Okay. So, and again, notice that if you negative, whatever you picked in here, the squaring always creates positive numbers. If you pick any values other than a is equal to 4b and c is equal to 6, you're going to, even if you have negative inside, the entire object, the entire expression will be positive, right? So this is clearly the minimum. They might call it absolute min or global min, but this is a minimum value for the entire expression. Okay? All right. That does it. Thanks for reviewing.